CD is a right angle. What led us to that conclusion? You got it. Def of perpendicular. Okay, so now we want to always end with what we want to prove. What is it that we want to prove? We want to prove that angle 1 is a complement to angle 2. Who thinks they know the reason for this? Thinks they knew the reason for this? Well, what is the definition of comp angles? What's the definition of complementary angles? Two angles that what? Noah? Good. I love that he said equal a right angle first, and then he said or add up to 90, because we don't have 90, but do we have a right angle here? So a comp angles are two angles that add to a right angle. So do we have two angles that make that right angle? Yeah. So isn't that the definition of comp angles? So we can say def of comp angles. Okay, so today we're going to learn some new properties. Let's start off with this problem using numbers. So it says AB is congruent to CD, so I'm going to label that. So I put a slash on AB. I put a slash on CD. Then it says AB is 8 centimeters long. Well, if AB is 8 centimeters long, do we all agree that CD also has to be 8 since they're congruent? And then it says BC is 3. So we want to find the length of AC. Can somebody tell me how long is AC? Noah? 11. Find AC. AC is 11. Can somebody tell me what did we add to get AC? 8 and 3. Can somebody else tell me the segments that we added to get AC? Jack?
AB and BC.
You got it. We added AB plus BC. All right, now they want us to find the length of BD. Can somebody tell me how long is BD? Is BD? Jack? 11. Can somebody tell me what did we add to get the 11? What did we add? Jay, what did we add to get the 11? Excellent. We added, oh, no, the other side now. We already got AC. So now we're finding BD. What did we add? To get BD. CD with what? With AB? No. With BC. So to get BD, we added BC plus CD, or CD plus BC. Okay, so what is it that I want you to take from this? We started off with two congruent segments. We started off with A, B, and CD. Didn't we add BC to both of them? So if we start off with two congruent segments and we add the same segment to both of them, guess what? The results are still congruent. How do these segments compare? Well, AC is 11, BD is 11. Aren't they congruent? So if we have two congruent segments and we add the same segment to both of them, the results are still congruent. And that makes sense. If we have two things that are congruent and you add the same thing to both of them, you're still congruent because you added the same thing to both of them. And the same idea with angles. So here it tells us angle EFJ is congruent to angle HFG. And then it says that angle EFJ is 45 degrees, which means angle HFG, since they're congruent, is also 45 degrees. And angle HFJ is 30 degrees. Now it's asking us to find the measure of angle EFH. This big angle here. Can somebody tell me what's that measure of angle EFH, that big angle?
75.
75 degrees. Can somebody name me the two angles we added together to get that 75 degrees? What two angles did we add together to make that 75 degrees? Stella? EFJ plus angle JFH. You got it. All right, now we want to find angle GFJ. So let's look. Angle GFJ is this angle here that I have in blue. Is also 45 plus 30, which is 75. And the two angles we added for there are angle GFH plus angle JFH. All right, what is the point of this problem? What is the moral of the story? The moral of the story is if I have two angles that are congruent, so I had EFJ and GFH were congruent. They told us that in the given information. And didn't I add that same angle to both of them? So I have two angles that are congruent and I add the same thing to both of them. The results are still congruent. So how do they compare? They are congruent. No, I was just showing you. All right, in proofs, the addition property, use the addition property when proving that segments or angles are bigger than the given segments or angles. All right, so that's the addition property. Let's talk about the subtraction property. So here we have WY is congruent to XZ. We have that WY is 12, which means that XZ also has to be 12 since they're congruent. Then it says that XY is 4 units long. Okay, so we now want to find YZ. Can someone tell me how long is segment YZ? What's the length of it? It's the length of just YZ. Noah's holding up the class today. Noah? 8, you got it. Jack, could you tell me what we subtracted? No, Jack in the back. Yep, we subtracted 12 minus 4. Could you name me the segments that we subtracted? So it was XZ minus what? You got it. All right, now we want to find WX. Can somebody tell me how long is WX, Caitlin? 8. Could you tell me what we subtracted? YW, yeah, minus XY, right? YW minus XY. So what's the moral of the story? I started off with two congruent segments, WY and XZ. And didn't I subtract XY from both of them? So I had two congruent segments. I subtracted the same thing from both of them. Were the results still congruent? Yes. Is WX congruent to YZ? Yes, they are congruent. It's the same idea with angles. So going on to this next one. So we have angle EFH, this big angle right here, congruent to angle GFJ, this big angle over here. They're saying EFH is 50, which means GFJ is also 50. And then GFH is 10. So now we want to find angle EFG. To find angle EFG, do you guys agree I'm going to do 50 minus 10? That's going to give us 40. And then we want to find angle HFJ. That's this angle right here. Again, do you agree we're going to do 50 minus 10 and get 40? How do these angles compare? They are congruent. What's the moral of this story? The moral of the story is if I have two angles that are congruent and I subtract the same thing from both of them, the results are still congruent. So in proofs, use the subtraction property when proving that segments or angles are smaller than the given segments or angles. All right, something new, the reflexive property. The reflexive property tells us any segment or angle is congruent to itself. And I'll show you how we're going to use that. Let's get into our proofs. So I'm looking at my given information and I'm going to mark it up. So I have segment AB is congruent to segment FE. And I also have segment BC is congruent to segment ED. So I went through, I marked my diagram with the given information. What's always the last statement in a proof, Stella? What we're trying to prove. This time, what are we trying to prove? We're trying to prove that segment AC is congruent to segment FD. So let's look at it. Segment AC goes from A to C. Segment FD goes from F to D. Okay, let's look at this. Aren't the parts of the segments congruent? Like AB is congruent to FE and BC is congruent to DE? If the little parts of the segments are congruent, do you think the full segments are also congruent? Yeah, let's just put in numbers just for fun. You guys don't write this down, I'm just showing you. If BA is 5 and E, that means EF also has to be 5, right? Because they're congruent. If BC is 2, that means DE also has to be 2 because they're congruent. What is the full length of the segments? 7. What did you do? Add. This is addition, guys. This is addition without numbers. So this is showing us that if the parts of the segments are congruent, I could add those parts together and get the full segments also congruent. So this is going to be addition. This is addition without the lengths. Mm-hmm. 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 All right, number 2. So this one's a little bit trickier and there's a new step in it that we haven't seen before. So our given is segment AB congruent to segment CD. So I wrote it in my proof and now I'm going to mark it. So segment AB congruent to segment CD. Then we're going to look at what we want to prove. We want to prove, I'm going to highlight it, that the full AC is congruent to the full BD. That's what we want to prove. Right now, I don't have the full AC congruent to the full BD. All I have congruent right now is segment AB and CD. Do we agree? But I don't want just AB. Don't I want A to C? Now, to get from A to C from AB, wouldn't I just add BC to it? If I add BC to AB, wouldn't I get the full AC? And now I don't want just CD. I need the whole D to B. Well, if I take CD and I add BC to it, wouldn't I get the full DB? All right, so I had two congruent things. And then I realized I want to add that same segment BC to both of them, right? So I had two congruent things. I wanted to add that BC to both of them. If you have two congruent things and you add the same number to both of them, are you still congruent? Yeah, but because I'm using BC twice, what you want to do is you want to put an X on BC. And in step number 2, we're going to say that we're using it twice. And the way to declare that we're using it twice, we say that BC is congruent to BC reflexive. And then I can say what I want to prove, which is AC is congruent to BD. And that's addition because I added BC to both of these segments. I know, maybe it's a ghost. Jack, I'll give you a minute to write it down before we move on. We good? Awesome. All right, let's see another one. Angle NOP. So let's write this out in our proof. Our given information, we're writing it out. Angle NOP is congruent to angle NPO, and angle 3 is congruent to angle 4. So we have angle NOP, that's this angle right here, is congruent to angle NPO, that angle right there. And we have angle 3 is congruent to angle 4. We want to prove that angle 1 is congruent to angle 2. We got to think of our reason. Okay. Well, do you guys see that the full angle by O is congruent to the full angle by P? And the bottom parts of the angles are also congruent. So if the full angles are congruent and the bottom parts are congruent, don't the top parts also have to be congruent? All right, but what is that? So I gave you the bigger angles, right? And I want to prove a smaller part of it congruent. So we're going from bigger to smaller. What do you think that is, addition or subtraction? Subtraction. So for addition, you make things bigger. For subtraction, we're making things smaller. So since I gave you the bigger angle and I'm proving a smaller part of it, that's subtraction. So we're going to say angle 1 is congruent to angle 2, subtraction. All right, number 4. So we're going to write out our given. And then I'm going to mark it. So GJ is congruent to HK. Now I'm going to highlight what we want to prove. We want to prove that GH and JK are congruent. Right now, I don't have that they're congruent. Right now, I have bigger segments, right? I have GJ and HK bigger segments congruent. So how do I go from the bigger segments that are congruent to the smaller ones I want? What would I have to do? Caitlin? You got it. What am I subtracting? Which segment am I subtracting? You don't know? Does anybody know? If so, to go from the bigger brackets that we have congruent to the smaller highlighted segments, which segment do I have to take away? Jack? HJ. Do you guys all see that we have to take away HJ? So since I would have to take away HJ from GJ, and I would have to take HJ away from HK, I'm using that HJ twice. I'm subtracting it away twice. So what did I say when we add or subtract something away twice? We have to declare it in our proof by saying it's reflexive. So we're going to say HJ is congruent to HJ reflexive. That's how we declare to the reader that we're using this twice. And now that I declared that I'm using it twice, now we can do what Caitlin said and say that GH is congruent to JK subtraction. We went from bigger to smaller, that's subtraction. Yeah, I'll get it from him. All right, almost done, guys. One more together, then two on your own, and we're done. So here we have that angle AEC is a right angle. So we have to mark that angle AEC is a right angle. Marked it. But then it also says that angle BED is a right angle. I mark that. And then I'm looking at my next step. It says right angles are congruent. That was a theorem we learned, right? Right angles are congruent. Which angles do you think we should be stating are congruent in the statement since it says right angles are congruent? Noah? So say it one more time. Well, one's not a right angle by itself. So we need to use three letters.
Oh,
Say it one more time.
I read it wrong. AEC and BE.
You got it. So we're going to declare the two angles that we marked as right angles that they are congruent. So angle AEC is congruent to angle BED. Is anybody confused to why that's the statement that corresponds to the right angles are congruent? Were you all good with that? Okay. Then it's saying angle 3 is congruent to angle 3. Well, what did we just learn? What was the reason that anything's congruent to itself? What's the reason that anything's congruent to itself? What did we write? Go back and look. So we said HJ was congruent to itself. And then two problems above that, we said BC is congruent to itself. Somebody knew. What's the reason anything's congruent to itself? Jonah? Reflexive, you got it. And what do we end with? We always end with what we want to what? Prove. So we want to prove that angle 1 is congruent to angle 2. Well, let's see why. So we agree that these right angles are congruent, right? And what we want, we have the two congruent right angles. We want just parts of those angles. Well, in order to get from these right angles that are congruent to angle 1 and angle 2 just being congruent, wouldn't I have to take away angle 3 from both of them? So I had two bigger angles congruent and I'm proving a smaller part of them congruent. What is that when you have something bigger and you're proving a smaller part of them? Which one is that? Subtraction, you got it.
Wait, can you explain like versus reflection? What does that mean?
So you had missed the beginning of the lesson, but we had said that the reflexive property tells us anything is congruent to itself. And so when we're adding the same angle to two different angles, or we're subtracting the same angle away from two different angles or segments, depends, could be segments also, we always have to declare that we're using it twice, and that's the reflexive property. Okay, guys, I want you to try independent 6 and 7. Let me check your 6 before you go on to 7. I will show you how it should be marked. Perfect.
This is Unit 4 Day 2.
Unit 4 Day 2, yeah. I am recording for you, Leilani, so you could watch the beginning of the lesson. Excellent. Perfect. Oh, don't forget your angle symbols. You marked it wrong, and that may be why. You mark it angle 1 to be only angle 1 to compare to angle 2. No, you were right with leaps, but you marked the wrong angle 1 compared to angle 2. And now a different marking for angle 3. That's the same marking, so you have to make it different. How do we make it different? Yep, perfect. All right, and now we're proving, so these small parts are congruent, but we're proving the bigger equals congruent. So what do? When we got the smaller parts congruent and we're proving the bigger one, that's not subtraction, addition, you got it. Anybody ready for me to check number 1? Or perfect. Hey, Sebastian. Excellent. Perfect. I love it. You did it perfectly, but you noticed it out. Like I was I was fine. Yes, like that. I know what's happening. But I didn't know, feel like nothing was there. So what was, okay. So do you see how you have WY and XC? And what we want to prove is WX and ZX. Well, to get from these bigger things congruent to the smaller things congruent, we have to take away XY from both of them. Because we're taking XY away from both of them, that's why we have to do this step. Okay, so since you're doing both, then you have to prove that those are. Yeah, like saying I'm using the same number twice, essentially. Yes, you do have homework. I will post it for you. Perfect. Oh, so what am I doing here? Oh, that I'm sure. Yeah, so depth of compass here. Then I'm confused on what else. So how did we know that this was a right angle? But we know that, so it would be depth of compass. Yes. Black. Anybody ready? Do you need help or are you still ready? Okay.
Yeah.
Okay. So let's mark what we have. Could you mark that WY is congruent to XZ? Show me how you would mark that. Nope. So that's showing WX.
Good. Okay, now what we want to prove is WX this segment and this segment. So do you agree we're going from big to small? So this is bigger and we're proving smaller. So what is that going to be? When you have bigger and you go smaller. Subtraction. So we know this last step will be subtraction. So now we're just missing that middle step, right? So now we want to ask ourselves, well, what are we subtracting? When we have the bigger segments, don't I have to subtract away XY to get to the smaller ones? Because I have to subtract XY from the left and XY from the right, I'm using it twice. That's when we do that whole reflexive property right there. So we say whatever we're using twice is congruent to itself. So you're going to say XY congruent to XY. And your reason is reflexive. Anybody need my help with the second one? So can you mark what's given? Mark WY is congruent to density. Yeah, that works. You don't need to think what, that's your mark over there. There, okay, that's fine. All right, so now what we want to prove is WX converges to YZ. Let's highlight those. Highlight, mark out to yellow, just highlight what we want to prove now. The WX and YZ. Okay, so do you agree? We have bigger segments congruent, but we want to go smaller. So if we're going from big to small, what is that? So that last step is going to be subtraction. So let's write that down and then we'll figure out the middle step. Does that make sense to you? Okay. So now we got to look at, okay, well, there's the middle step, so I'm missing something. What am I subtracting away? Well, to get from WY to WX, aren't I subtracting away XY? And to get from XZ to YZ, I'm again subtracting XY. Because I'm subtracting XY twice from the left and the right, that's when we have to declare that we're using it twice. So the way we do that is you say it's congruent to itself, XY is congruent to itself, XY congruent to XY. That the first should be. And your reason is reflexive. And the second one's.
Wait, Mrs. A, did you post on one? Perfect.
Now, okay, good. You marked up your diagram well. And now let's highlight what we want.
Jack. You have to move. What? Yeah.
Okay. Now, do you agree? We have the bigger segments here and we want to go smaller. No, if we're going from big to small, what is that? So we know the last reasons for that. So now we have to figure out the mechanism. So now we're going to look, okay, well, what are we subtracting?
No, like,
To get to such big segment, to get a smaller one, don't I have to take away X, Y? And then I have to take away X, Y, so, and then if it's a small one, so I think is we put into there, that we're using it twice. So it might be X, Y, and one of the.
yeah, it's like what's that?
And the reason is reflexive. Anytime we say seconds to the itself, our reason will be reflexive. Okay, guys, I'm going to go through this for anybody I didn't get to give personalized attention to.
Let's see. I think I checked everybody's number one. Do we agree? Or maybe not. Let's just go through this quickly. So this was angle 1 congruent to angle 2, angle 3 congruent to angle 4, and then we're proving angle EHG is congruent to angle FGH, and that's going to be addition. Because we have the parts congruent, and what we wanted to prove was the full angles congruent. So if we add their parts together, the fulls are going to be congruent. Now this one stumped a lot of people. So here we have WY is congruent to XZ. You have to mark your given information to figure this stuff out. So WY congruent to XZ. And what we want to prove is WX is congruent to YZ. Well, I'm skipping the middle step, jumping to the last step. Do you agree we have the big segments congruent and we're proving the smaller parts? So when you go from big to small, isn't that subtraction? So I know my reason for number 3 will be subtraction. Now I have to figure out that middle step. What am I taking away? Well, to get from WY to WX, aren't I taking away XY? And to get from ZX to just YZ, again, I'm taking away XY. Because I'm using XY twice, I have to say that I have to declare that I'm using it twice. So I say it's congruent to itself, and your reason is reflexive. Okay, I will post the homework key now. I mean, the homework.